Welcome back to The Explainer. So, if you're a focused learner looking to build AI products, automate your workflows, or really dive headfirst into the world of vibe coding, you are in the exact right place. Today, we're climbing what I like to call the builder's ladder. We're going to break down the escalating steps of building generative AI apps, cut through all the noise, and give you a structured, strategic path to actually follow. Because let's be real for a second, the paradox of choice in Gen AI tooling right now, it is completely overwhelming. You hear buzzwords like prompting, RAG, agents, and fine-tuning just thrown around interchangeably. But where do you actually start? Well, to make this crystal clear, I want you to think of your large language model, your AI, as a brand new intern. How you manage this intern, what tools you hand them, and how much autonomy you give them literally dictates everything about the cost, complexity, and ultimate success of your app. And that brings us to our baseline, vibe coding. If you're new to the term, vibe coding is simply writing software by directing an AI with natural language rather than, painstakingly typing out all the syntax manually yourself. You are the manager. The AI is the intern writing the code. But to be a good manager, you've got to know exactly how to direct them. So let's step on to the very first rung of our ladder. Rung 1, prompting the starting line. Look, before you build complex infrastructure, you always start right here. Prompting is simply giving your intern clear, explicit instructions. It's the cheapest, fastest, and absolutely lowest risk solution available. If you're a beginner, here is exactly what you should build first. Seriously, don't jump straight to autonomous agents. Start with a basic prompt template that clearly defines your intern's persona and task. Then implement a self-refining loop. Just ask the AI to critique its own output by saying something like, suggest 3 improvements to this code. Finally, wrap that in a simple API interaction. You'll honestly be amazed at what just good prompting can pull off. Rung 2, RAG, providing knowledge. But eventually, your prompt is going to hit a wall. You'll ask your intern about your private code base, or maybe some recent data, and they'll just stare blankly at you because base models have strict knowledge cutoffs. That's exactly when you step up to Retrieval Augmented Generation, or RAG. Think of it like this. If prompting is talking to your intern, RAG is handing your intern the company handbook right before you ask them a question. A vector database searches your private data, grabs the relevant chunks, and injects them directly into the prompt context before the AI even sees it. And this perfectly illustrates a massive misconception in the AI space. People always think, oh, I need the AI to know my company data, so I have to fine-tune it. No way. Actually, RAG is cheap, it's fast, and it relies on real-time, verifiable facts, which massively reduces those pesky hallucinations. Fine-tuning, on the other hand, fundamentally alters the model's underlying weights. You really just want to use RAG when you simply need to add specific knowledge. Rung 3. Function calling, taking action. Okay, so your intern is smart, and they've got the handbook. But what if you actually need them to do something in the real world? Like, say, look up a live exchange rate, or trigger a deployment. Well, this is function calling, where you hand your intern a specific tool. Now, it's absolutely vital to understand this. The AI doesn't actually run the code itself. Instead, you define a structure, like a JSON format, and the LLM formats its natural language response into that exact structured data. Your app then takes that and triggers the right tool on your end. Pretty cool, right? Rung 4, AI agents, adding autonomy. Now we're getting into the really fun stuff. This is where we transition from triggering a single specific tool to granting full autonomy. We're talking the absolute cutting edge of Gen AI right now. Rung 4 is AI agents. This is where you basically let your intern plan their own day. Instead of one single prompt, you give the LLM access to an entire toolkit and a state, which is basically a memory of its past actions. Using frameworks like LangChain or AutoGen, the AI can hold a conversation, write some Python, execute it in a sandbox, see the error, and rewrite it until the task is completely done. Let's quickly walk through how this workflow actually plays out. An agent receives a really complex request. First, it plans the tasks. Then it might trigger an API to fetch some data. It reads that result, realizes it needs to process the data, so it writes and tests a Python script, and finally it delivers the output. It is a massive, massive escalation in both complexity and power compared to just a simple single-function call. Guardrails, security, and LLMs. All right, let's pause our climb for just a second. Because if you're going to let an autonomous intern run wild with access to your APIs, you need armor. The security risks here are incredibly real. You've got prompt injection, where bad actors actively try to trick your LLM. You've got data poisoning in your training sets, supply chain vulnerabilities in AI plugins, and probably most commonly, over-reliance. That's when you blindly trust an AI that is hallucinating and just entirely fabricating code. So, the crucial takeaway here is that we have to shift our mindset to LLM ops. Evaluating, testing, and monitoring your AI code is just as important as writing it in the first place. We have to continuously track 5 key metrics: the quality of the response, the potential for harm, the honesty or groundedness of the output, the latency, and of course, the cost. Trust me, if you aren't monitoring these, your little vibe coding experiment will very quickly become a production nightmare. Rung 5, the fine-tuning trap. Now that we're nice and secure, let's explore the very top of the ladder. And honestly, it's a very expensive trap that a lot of beginners mistakenly try to jump to first. If RAG is giving your intern a handbook, fine-tuning is sending your intern back to a 4-year university. It is the process of fundamentally retraining the model's core weights and biases. That requires massive compute power, incredibly clean data, and some serious machine learning expertise, just so you don't accidentally degrade the model's baseline intelligence. Listen closely on this one. You should use fine-tuning only when you hit very specific roadblocks. For instance, if token limits are blocking your massive prompts and it's just getting way too expensive, or if your latency needs are incredibly strict and you need a smaller, specialized model to run super fast. Or if you are teaching the model an entirely new format, behavior, or skill that it fundamentally just does not understand yet. But again, it is absolute overkill for simply adding company knowledge to your app. The ultimate decision tree. Okay, let's bring this all together into a really practical, strategic guide so you know exactly which tool fits your specific problem. Here is your rule of thumb matrix. Need to instruct the model? Use prompting. It's low cost, low risk. Need to give it private knowledge? Use RAG. It's medium complexity but highly verifiable. Need us to take a single structured action? Function calling. Need it to plan multi-step workflows? That's when you use agents. High complexity, high power. Need to teach it a completely new core behavior or maybe save on token costs at a huge scale? Only then do you pull out fine-tuning. I want to leave you with this final kind of provocative thought to really anchor your builder's mindset today. The next time you sit down to start vibe coding, before you architect some massive autonomous agent swarm or spin up ridiculously expensive GPUs for fine-tuning, just ask yourself, could a really good prompt have done the job? Always, always start on the first rung of the ladder and only step up when you absolutely have to. Thanks so much for joining me on this explainer, and hey, happy building.